Okay, here's a quick recap on yesterday's ellipse. Okay, so I had a minor circular radius 50, major radius 75. Draw the big axis line across the middle, that's the major axis. Then the minor axis, okay, vertically contained within the minor circle. And you can see I'm just labeling the different features. And now what I'm going to do is I'm going to divide up that circle using my 60-30 degree set square. 30 degree line, 30 degree line, 60 degree line, and 60 degree line. Now what I'm going to do is I'm going to focus on drawing my little triangles that contain the points on the curve of the ellipse. And you can see in this version I just speed that process up. Okay, to contain all those points, I highlight the points. I now take my pencil very lightly and I do the light version of the ellipse first. And I'm reasonably happy with that. Now I get my darker pencil or my drawn pen and I complete the ellipse. Okay, so that quick recap from yesterday hopefully has helped you refamiliarize yourself with the processes and steps and stages involved in drawing the ellipse. As you can see, as explained, went through all the various parts, minor, major, dividing it up, getting your triangles, getting your points, and drawing the curve. Now, the element we want to add in today is what are called focal points. Okay, so focal points. There are two contexts with which we look at focal points. The first one would be that they are two fixed points that when you attach them to the curve through a series of lines, you will get a constant distance between the 2 points and the curve. And I'll demonstrate that in a moment. Now that might sound a bit abstract to you right now, but when we see it happen physically, it should make sense. The other way we look at focal points is if we imagine what is called conic sections. That's where we take a cone. Now you can picture a traffic cone or some conical object, and if we cut that object at an angle less than 45 degrees, we would produce an elliptical surface. And if we were to take the bit that was cut at the top of the cone and the bit that was cut of the cone underneath, and we were to put a ball, like a tennis ball, into the top of the cone, the one that fits perfectly into the cut space, and then one in below, well, those two balls, top and bottom, would give us the points of contact with the elliptical cut surface, and they would also be focal points. Now, that's for more leave-insert drawing, and that's something that we would graphically represent more in the questions you would have at, say, leave-insert level. But at junior cert level, focal points, the simple, most abstract way to understand them is that they are two fixed points that when we link them to the curve, we have a constant distance that will allow us to actually produce the curve. Okay, so how do we locate these focal points and where might they be? Well, focal points are always located on the major axis, so that's the long axis line. Okay, so this line here that I'm highlighting. And what I do, and this is the trick with it, well, it's not a trick, it's just a method. So I'm going to take my compass, which is probably the most reliable way to do this. Take your compass, and I want you to put the point of the compass at point 0, okay, and stretch it out to the major circle, like so. Now, what we have there on our compass is essentially the major radius, okay? And what we can do here is we can now take the point of the compass and move it to the top of the minor axis, this point right up here. So I'm going to place the point of my compass there, and I am now going to swing an arc to intersect the major axis here, and likewise on the other side. That has given me 2 points, there and there, and they are my focal points, F1 and F2. F is short for focal, and 1 is the first point and 2 is the second point. And just for clarity's sake, if you were to take that major radius and go to the bottom of the minor, you can also swing the points from there and they will align exactly in the same position. Okay? So you can swing your major radius from the top or bottom of the minor axis to get your focal points. Now, what is the significance of that? Well, let's highlight a simple plain truth here for the moment. I am going to call this point P here, the top of the minor, point P. And I am going to join F1 to P, like so. And I'm going to join F2 to P. Okay. Now, here's the funny thing. Okay. If I add up, if I measure the length of this line here, okay. Actually, before I do that, I'm going to measure the length of the major axis. It's 150. Okay. So major axis, we'll call that major axis equals 150. Okay. Now millimeters, of course. Let's not forget our units. I'm going to now measure the length of the line F1 to P, and that's 75. So F1 P, we'll call it like that, we'll put a line either side representing distance, equals 75 millimeters. And F2 to P, okay, I'll just measure it from P down, is also 75. So F2 P equals 75 millimeters as well. So if we add up the length of both of those lines together, what's 75 plus 75? It's 150, isn't it? M. Okay? So 150 millimeters. And that is equal to the major axis. Okay? Now that's no coincidence. Okay? I'm just going to write that. F1P on that one and F2P on this one, just so we can relate back here. So, when we add up the length of both of these lines, it gives us the length of the major axis. Is that something else? Well, let's have a look at another example. Let's say there's a random point there on the curve. Let's say we call this point, we'll call it point X here. You'll see this point X. What I'm going to do is I'm going to join a line from F1 to X. And F2 to X. Now don't be confused by all of these lines now, alright? Just focus on the 3 points there. So we've got that F1 to X, F2 to X, almost like that triangle there. Okay? Here's the thing. Let us measure again. F1 to X, F2 to X. So I randomly place that line, point, and it's 43 millimeters. Okay? So I'm going to write it down here. F1X equals 43 millimeters. Now I'm going to measure F2 to X. Well, that works out at 107 millimeters. So F2 to X equals 107 millimeters. Okay, if we added both of those together, what would we get? 150 millimeters. And of course that is equal to the major axis again. Alright? So no matter what we do, if we have a point on the curve of the ellipse and we join it back to F1 and F2, when we add up the length of both of those lines we've created, it will always equal the length of the major axis. Okay? And that's really important to note that. Okay? So just bear that in mind.